All right. We are going to start Objective 18 today. We are going to solve triangles using the law of sines, okay? And I know what some of you are thinking. You're thinking, Ms. Corns, can't we already solve triangles? What kind of triangles can we solve? We can solve right triangles. So, does everybody have this part down? Nope. Okay, let me pause. Okay, so let's look at what we know already. Okay, so I want you to take a minute with this triangle, and I may have to restart. I'm going to have to. Let's put a right angle in the corner of this so we actually make it a real right triangle. I want you to take a minute and solve that triangle. When I say solve a triangle, what do I mean? Find all the sides, find all the angles. Okay, so let's review what we know, and let's solve this triangle, and then we'll go into what we're doing today. Okay. Based on what we know, first of all, what's this angle up top? 38 degrees. Okay. And let's label this side X and this side Y. Okay. So somebody, and there's different ways to do this. Anybody want to tell me how you figured it out to set up X? Okay, so the tangent of 52, so if we look at the 52-degree angle, what's the relationship? Opposite, and then we would do 35 would be adjacent. So that would be the tangent. So that would be X divided by 35. So to figure out what X is, we're going to times both sides by 35. So what does X come out to equal? Rounded to the nearest tenth. 40 what? 44.8. Okay. And anybody do it differently? Could you have used, let's see, this would have been the tangent of 38 could have been 35 over X. Does that make sense? The opposite over the adjacent, and solved it that way. You could have done that, and it would have given you the same answer. Okay? And there's lots of ways. Now that we know two sides of a right triangle, there's tons of ways to find the third side. What's one way? Okay, you could do a squared plus b squared equals c squared. That would be fine. Okay, which two sides would be your a and your b? The 44.8 and the 35. How many did Pythagorean theorem? Okay, so I had some that did that. Anybody use trig? How did you set up using trig? Anybody? What'd you get, Seth? Cosine of 52. 35 over y in this case, right? And so he times both sides by y, and then so y times the cosine of 52 is equal to 35, and then he divided by the cosine of 52, cosine of 52, cosine of 52. So what does y equal? So did you use Pythagorean theorem or did you use trig? Because here's what I want to do. What did you get doing this? 56.85. Did you get 56.85 using Pythagorean theorem, or did you get something different? You got the same thing. I will tell you this, depending on, sometimes when you do this, like if you do the Pythagorean theorem versus if you do it using trig, depending on what you round to, it may throw the decimals off a little bit. Does that make sense? Still round about the same answer, but doing it different ways, just because we are rounding the versions, they may throw your decimals off a little bit. So what'd y'all say, 56.8? Yes? 56.8. Okay. Any questions on, this is what we know so far. This is how we know to use it using right triangles. Okay. So the question came up yesterday is, what do I do with this? Solve the oblique triangle. Oblique triangles are triangles that have no right angles, by the way. So my question is, can you do what we've already done? Could you say, I don't know, use the, like, there is no hypotenuse. Does that make sense? You've got opposite sides and you've got adjacent sides, but there is no hypotenuse because hypotenuse have to be across from a right angle. So you're not going to be able to use what you already know. So that's what's going to be the thing coming into the test is which way do you do what. So from day one, I want you to understand if you have a right triangle, you can do what we've been doing, okay, using SOHCAHTOA basically, okay? If it's an oblique triangle, you're going to have to use something else. So one way to do this is to use the law of sines. So we're going to come back and solve this example 2 in a minute, but I just wanted to kind of show you the difference in the two. So we'll go back to example 2 and actually fix it. The law of sines says this, that in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles. Okay, so you can take the sine of A, the sine of that angle, over the side that little a, little b, and little c, lowercase, these are going to be your sides. Okay, the capital A, capital B, capital C, those are going to be your angles. And little a corresponds to the side that is opposite of angle A. Does that make sense? Little b, lowercase b, is the side that is opposite to angle B. And lowercase c is the side that is opposite from angle C. Okay, so we're going to use this to be able to solve our triangle. You let me know when you're ready. All right, so let's go and use our law of sines. You ready? So first of all, I need to decide whether I'm going to use, like, you're not going to use all 3 proportions at the same time. You're going to use 2 of them. Does that make sense? And then you end up cross multiplying and solve for the other. So let's first of all, let's find this missing angle. How are we going to do that? Okay, add those 2 up, subtract from 180. So do that for me and tell me what you get. Does everybody agree with 45? Okay, so this piece is 45. You need to decide which 2 angles, like which side and opposite angle, or which angle and opposite side do you have the complete set of? And that's going to be the one you're going to use. Like, for example, like, let's look at C. Do I have the side and the angle? No, so we're not going to use that as like our base. Do I have A? No. Do I have B? So we know we need to use these 2 right here to begin with. These are going to be what I compare to. So I can say the sine of 45 over, what's the side of B? 340. Now, decide which piece do you want to find. Do you want to find A or do you want to find C? Let's find A first. Let's go alphabetical. Okay, so what angle will we be using? 60. So what could I say? I could say that this is the sine of angle B over the opposite side of B is equal to the sine of 60 over A. And I will tell you, in order for this to work, like, how many pieces and parts do you have up here? You got how many total? 4, right? When you set up your proportion, you're going to have 4. So you will need to only have how many variables? 1 variable, and you'll have to have 3 parts. Like, you've got to have 3 pieces and 1 missing part in order to solve this. Does that make sense? You can't set it up to find A and C in the same problem. Does that make sense? You're going to have to find A and then set up another problem and find C. Okay? So I'm just going to cross multiply. okay, when you do this. You could, I mean, there's all kinds of ways. You could say, ooh, yuck, disgusting, nasty, let's multiply everything by 340a, and that's fine. And that works too if you'd like to do that and multiply both sides by 340a. But I'm just going to cross multiply. So this is going to be the sine of 45a equals the sine of 60 times 340. Okay, so to solve for a, what will I do? I'm going to divide this side by the sine of 45. So, and here's what I'm going to tell you. So, because you know this is going to give you some like crazy decimals so that you don't have to write those decimals down, I'm going to show you how to put this in your calculator all at once. Now, you cannot just do, well, actually, I think you could do the sine of 60 times 340 and then divide it by the sine of 45. But just to be safe, I'm going to have you put the top in parentheses to make sure you work the whole top and then the bottom. So let's put in the sine of 60 times 340 and then we're going to take that and divide it by the sine of 45. So what do you get? Let's round to the nearest, let's go ahead and just round to the nearest whole number. 416. Okay, so we know A is 416 miles. Okay, how would you set up C? Anybody? Do you want to use, like, could you use the combo of A instead of the combo of B this time? You could, but you know what I'm going to do? I'm going to leave the combo of B the same. Does that make sense what I'm saying here? Like, I'm going to use this again, the sine of 45 over 340. That's the angle of B over the side of B is equal to what? If I want to find C, Jacob. If I want to find the missing side of C, what can I say using the law of sines? Find the one that says C. Okay, so do I know the capital C means the angle of C? Do I know the angle C? So the sine of over, and I don't know the little c, so I'm going to find that. Okay, does that make sense? And then I'm just going to cross multiply. So if I cross multiply this, what will I have? Sine of 45 times c, and this will be sine of 75 times. Okay, now tell me, how would it solve for c? So I'm going to divide by the sine of 45 on both sides. And again, just to be safe, I'm going to put it in parentheses just to make sure that it will work out. So what's the sine of 75 times 340? Nope, that's not what I wanted to do. Make sure to, so can I say this too? When you type in sine, it's going to like throw a set of parentheses there. You got to make sure to do what after 75? You've got to close that parentheses. Because what it will do, it'll take the sine of this times this and take the sine of all of that. Does that make sense? So make sure you close that and make sure it just does the sine of 75. Okay? So the sine of 75 times 340, and then we're going to divide that by the sine of 45. What will you get? Rounded to the nearest whole. 464. Okay, and that's miles. How hard is this? Not hard. Okay, opposite angle, opposite side for each piece. Okay? All right. So here's what I want to know. I want to know for each of these pieces, do I have enough information to solve this? Okay, so let me just label these A, B, C, D, E, and I want you to tell me this is A, this one's B, this one's C, this one's D, and this one's E. And I want you to talk with your groups and tell me which ones you have enough information that you can do the law of sines, and which ones you don't have enough information that you could not do the law of sines. Okay, does that make sense? So if I look at B, and I'm going to do the law of sines. Basically, this says the sine of angle A over the side opposite of A has to equal the sine of angle B over the side of B. Well, my question is, I told you just a minute ago, in any proportion, you have 4 parts. Does that make sense? How many pieces do you have to have in order to solve? You have to have at least 3. Do you understand? So if I don't have an angle here and I don't have an angle here, because I don't have any of these angles, could I use the law of sines and solve? Yes or no? No. Okay, so B, I don't think you can solve. How about A? Yes, you've got enough. You've got an angle, and you could find the third angle, and then you would have a corresponding side, and then you could find the other pieces. So A would work, okay? How about C? You have a corresponding pair, right? You have this angle with this side, right? So that would be a piece, like let's say this is A. So you would have an angle A, and then you would have a corresponding side with it, and then you would have another side, so then you could find the corresponding angle that goes with that. So that would work. Does that make sense? So that one could work. How about D? Yes, because so you could find the third angle, right? Yes, if you were given that, so that would work. How about E? Why not? Well, you got this angle, but up here we only have one angle. Or no, wait a minute, where am I at? Right here I only have one angle in C, but I've got the corresponding side that goes with it. On this one, go back please. On this one, I don't have the matching side, the corresponding side that goes with that angle. Does that make sense? So it's not, I could not use that pair. And then I don't have the other 2 angles to be able to use those 2 sides. So this one, I do not think, I can't X it out, but you would not be able to do it. Do you understand what I give up. You can't do E. Does that make sense? You can't do E. I'm just going to kind of exit out imaginary, okay? Everybody understand? Like, you got to look. And so, what do you do when you can't do a certain way? You got to find another way to do it. Does that make sense? But I'm just talking about for law of sines. You've got to have at least one pair of corresponding angle and side in order to set up and find a missing piece of another part. Okay? So, we've already done this one. Let me go to example 3. Okay? So my question here is, would you be able to do this one? Yes, because you have at least one set of corresponding angle with the side. Okay? So I'm going to give you a couple minutes, see if you can solve it and set it up. So I'm going to end my recording right here. If you will, finish this example out, and we will pick up with this example on Monday.